So here's an example of a simple drivetrain and arm for a robot. We learned how to build a claw. This claw is from the Yale site for a claw. We took the base of the robot and we made it from the Rev site for FTC. We modified it a little bit. We took the arm and put it on a long piece there. And what we'll see is we can actually use this to pick up blocks and glyphs. So hopefully your arm is already programmed. Sorry, we can pick up blocks and solar panels, and hopefully we'll see how this works on the field. We've wired it up, and instead of an expansion hub, you should have a control hub, and the battery will go over here. So, okay, so we're now going to actually build a structure to put on so that we can ultimately have an arm. I'm actually not going to go through how we built it. I'm just going to allow you to see pictures of this, and you can do this in multiple different ways. And what you'll see is I'll show you how to put it onto the robot in the next step. So we're going to put it onto our base of our drivetrain, and you'll see how it goes on. One of the things I want to point out is I did put metal brackets here, and you'll see how those metal brackets fit onto the rev train so that it will be structurally stronger. And notice that I use triangles to help keep the vertical rev straight. So see you in the next minute. All right, so we're going to slide this vertical piece on, but if you notice, I've also put a lap bracket here because after we slide it on, I want to put a lap bracket, a cross beam there. But that's going to go in between these two pieces. So one of the things I'm going to do is I'm going to add a lap bracket to the inside here, and as we're going along, it will slide along with that piece. So next thing you'll see is this whole thing assembled. One of the things you want to do is you might want to keep these pieces loose as you slide them on so it can move around a little bit, and then tighten them later. Okay, so now we're going to actually put motors that are going to drive our arm, and I'm just showing you how they go on. Notice one's straight and one's at an angle. If you notice each motor, it has an arrow in the direction in which the motor works. So the reason I have it this way is that way because here I'll have both motors going in the same direction, and that will give me, because they're both going to be chained to the arm. The reason we're doing two motors is to get higher torque. For the motor, we're going to use a axle, 3mm spacer, and a 20-tooth sprocket. And so we're going to basically put a collar on the other end and put this on. So now I've mounted the motors on the two sides. Leave the screws loose because we're going to adjust the height of these as we need to do. And now to work on the arm. Remember the claw that we built earlier. What we're going to do is we're going to attach the claw to a sprocket, and then it will be on a rotation here. We're going to chain those motors up to these sprockets, and so you'll start to see how this thing all comes together. Okay, so on our arm we've got the big sprocket connected to the arm. You can kind of see we have the 3 screws that are holding it right through the rev on both sides, and we have a 26-tooth sprocket. We have a shaft hub, and then we have a, just to give you a sense, we have a bushing and a pillow block on one side, and later we'll put a pillow block on the next, and this whole attachment will go onto the arm. So what we're going to do is we're going to put the pillow blocks on here. I'm going to get this one on the side, and we're going to get the second pillow block over here. And now, if you notice the arm is going to go into the front. Let's get this in. And now what I want to do is I want to actually see what point does the arm go to the ground. So notice this is a really nice height because now the arm can go to the ground, and I'm going to lock the pillow blocks in space there in place. And I'll come back and I'll use a ruler to actually measure. Okay, stop. In my last shot, I forgot to say, you probably need collars here and we're going to center the arm on this axis. So let's go do that. Okay, from the side what you can see is our motors have to be adjusted. So if we put the chain and actually have this on the wrong side, I'm going to want to have this sprocket come to the front. But this is the nice beauty of chain, is it doesn't matter, it can stay on this side. So I'm going to adjust my motor height so I can ultimately put chain, and it's going to be right around here. Now we have the motors mounted, and what you'll see is we can do the chain between those two sprockets. If it would have been nice, I could use the big sprockets if I had more, but this is what we have right now. So, and if we had more color, we would probably put some collars here and collars around the sprocket. Okay, so you might have this built now. So let's look at some of the challenges with this robot. When you look at this motor, the way we've mounted it, you can see it flexes a lot, bends a lot. And that's because we use this type of mount. And it doesn't seem like it bends a lot here, but because of the torque, you can sort of see it bends. Now, the advantage to this mount is that it has a right angle, and it's that triangle right there. And that triangle on the side creates a lot of strength. So bending forces are based on the cross-sectional area, so how thick this is or how wide this is. So what I've done is I've taken to the other side and I put the second motor with this type of a bracket, and what you see here is that motor doesn't actually move, doesn't bend. So what we're going to do is we're going to put this motor bracket on for these motors. The second thing you want to think about when you're attaching your motor, when you're building, is always thinking about these angles. And so notice we have the triangle here. The lap bracket actually here, you can see actually secures this beam to this side, and the lap brackets down here are very strong. What I'd like you to think about is where are things that could break on the robot, or where are things that don't work. And next we're going to actually put this together and then we're going to wire it. Alright, so now we put both the motors on, but a couple things you can see is that this sprocket actually can move, and so you may want to think about ways in which you could prevent that from moving. One way of doing that is adding some more shaft collars to both sides. The second thing you should notice is that these tilt, right? And even though these are strong, what you'll see is this can still move. So think of a way in which you could actually make this not bend as much, and what are good ways of doing that. And so I will let you think about that before you move on to the next section. Okay, so one way of getting those two to be straight is we put a long shaft between the two, and notice I made them so both chains are tense, right? Very tight. We don't want them to be loose, otherwise they will skip. And maybe we will talk a little bit. If you actually have big sprockets, you might put big sprockets on both so that they're the same. It would drive it 1-to-1, but we can talk about that later. All right. So next steps. Okay, for each motor there are 2 wires that we're going to use. One with 4 colors, black, red, white, and blue, and the one with black and red. The black and red are wires for power to the motor. Red is positive, black is negative. The colored wire is for the encoder. We'll talk about encoders later. That's for the basically like sensors. Black is negative, red is power, and the white and blue are different signals. So I actually like to keep my wiring very neat, so I will actually put zip locks or zip ties throughout because all these wires are going to be the same. I also like to label my wires. So for instance, at the end you can see it says left and it says drive, and this one says right and drive. So I took the right drive motor and I connected it to port 0, and the left drive motor and connected it to port 1. I'm going to take the right motor for the arm, and I'm going to connect it to port 2, and the left motor for the arm and connect it to port 3. Okay, so we wired up the motors, and one of the things you can see is I actually zip tied things together, and I put them connected to the rev extrusion in a way that it won't get caught, so that when my arm moves, you can see the arm moving, it doesn't get stuck. So I still have to do this servo, and there's a servo wire that you should find. Servo has the white and 2 blacks. One of the things you're going to need is a 3-wire servo, and I'll do that, but what you'll see is I'll also zip tie those together. So hopefully you'll see that in the next frame. Okay, so the servo is wired, and there's a connection to a wire that's white, red, black. The white wire must go to the white wire, and then that goes up, down to there. It comes around. I've wrapped it up so it's very neat, and then this will plug into the expansion hub, which is right here, which says 0. And the way it works is, notice it says a black, which is negative, a plus, and a S, which is white. The white has to go onto the right side. We're going to plug it into port 0. So let me show you that. It's a little hard to get to, but you can see it from here. So make sure it's plugged in all the way. Okay, and that's your servo port. I think we're ready to go try this out. Okay, so on the field, this is how we're going to program it. The arm is going to be able to move up and down. And we're going to grab the box by closing the servo. We lift it, and the block will go in. And in fact, it can get to the high position if we need to get it into that block. You can sort of see this arm can reach. It can drop a block there. Okay, so now let's see if we can pick up the solar panel. So with the solar panel, when the arm is wide, if you come like that, it comes up, you can put it down, grip it, and it should be able to pick it. Sometimes it might drop it, but that's because we have no power. We'll see how it goes, all right? All right, so hopefully this will be a good video for you.
This is how you're supposed to.
Well, you can do it both ways.
This is better.